So what I want to talk to you about today here in this talk is about GitLab-CI. And I'm going to make the ambitious claim that GitLab-CI is the new primary test infrastructure for Upstream Xen. And I hope that by the end of this presentation, we'll be convinced, as I am, that GitLab really is. So first of all, I want to disambiguate and be clear about this, because GitLab is many things to many people. It's a Git repository hosting service. It's, of course, a CI loop infrastructure, but it's also a wiki. It's a backtracker, code review portal, and more things. So I'm only talking about CI loop, right? I'm not interested in the other features. And if as part of this discussion, GitLab repository come up, it's only for the sake of triggering CI loop jobs. This is not about tickets. It's not about code or any other reason, right? It's only the CI loop infrastructure. And how does it work? So I'm going to try to introduce some basic terminology and names that GitLab uses, so that we can understand each other. So whenever you push to a tree on GitLab, whether it's a branch or an update on a branch or a new branch, to any of your repositories on GitLab, a pipeline is triggered. What is a pipeline? A pipeline is a collection of jobs. A pipeline is what you see on the right. Each job is basically a test. You can think of it as a test. So our pipeline is divided in two stages: the build stage first, and then the test stage. Each of these two stages have a number of jobs, and overall we have more than 100 jobs. So, like I said, for us, a job is really either a build or a test. If it is a build, so the jobs that you see on the left, is really building Xen on a variety of different containers, of different distros, from Alpine Linux, Debian, Ubuntu, you name it. And different configurations too. So we have debug builds, non-debug build, run config build, all sorts of builds. The test jobs are more interesting. So this is about actually, running a Xen binary that was previously built on the build stage. So running this Xen binary somewhere. So normally, most tests, we run it inside QEMU. So nested vert style. So we launch QEMU to emulate a full machine, and inside we run the Xen binary to see that it behaves as it's supposed to behave. But we do also, we are also capable of running the Xen binary on real boards, and I'm telling you more about it later. A GitLab runner is the thing that executes the job. So you have this job definition that typically is, please build Xen, or, run this script in this container. Someone needs to do it. The runner is the thing that does it. Is literally, in practice, is a software daemon for Linux. It's called GitLab Runner. It works together typically with Docker, and it needs to run on a Linux machine. All of our runners, I think, are not all. Maybe most of our runners are based on Ubuntu, but they could be Debian, could be anything. One thing that is interesting is the runners are tagged. So if you want to run an ARM job, the ARM jobs are tagged ARM64, and our runner, the ARM runner, which is kindly sponsored by ARM, is an Ampere Ultra, is also tagged as ARM. And this tag matching is what makes sure that ARM jobs are run by the ARM runner. x86 jobs are run by the x86 runner. So let's start with the build jobs. So I'm going to take the example of the Ampere Ultra that's been sponsored by ARM. There is also the x86 runner sponsored by Rackspace.
And Cubes.
But the hardware runners are kind of keeping them for a special segment. So these ones are the one that runs all of the build jobs. And what they really do is they execute the container that you define as part of the job. So let's say that you have a job with a Debian unstable container. So they launch the Debian unstable container you always also have the Xen repository already available inside. So the GitLab runner always takes care of making available at a known location inside the container xen.git with the right branch already checked out. So you enter the container, you're already there in xen.git with the right branch that you wanted to test. And the build job also specify a script. I mean, any job specify a script to run. And in the case of the build jobs, they all execute the same script, which is automation, GitLab-CI, so automation scripts build, which not very, unexpectedly, it builds them, right? Sometimes it builds only the hypervisor for architecture where it would be difficult to build, like ARM32. Typically, we only build the hypervisor. RISC-V, we build what we call the hypervisor for RISC-V. The few things.
With same for PowerPC now?
Same for PowerPC.
A couple of days ago.
Okay, so like I said, the runner checks out the container, runs the container, xen.git is there, and then you run the script that does whatever you want it to do. Test jobs. I mean, they work the same way. It's just that instead of building Xen, they're going to try to run the binary. So again, let's take an example of one of the many. Closer? Right. I'll try to stay still. All right. I'll take an example of one of the many QEMU-based tests that we have on ARM. So the way it works is very similar. So let's say that you define the test based on Debian unstable. Your GitLab runner, the same, running on the Ampere Ultra, cloning Debian unstable. You have Xen.git. Now, you not only have Xen.git, you also have Xen.git and the binaries that were previously built in the previous stage. You can select which of the output binary you want. So there is a way to say, I want these artifacts from this previous guy. So you get also the Xen binary ready, and then you execute the script as before. Now, this time, the script that we execute are many. Again, there are not just one, like in the build case. We have many. In the case of this example, is QEMU smoke dom0 less ARM64, which is the dom0 less ARM64 test. We also have x86 test that works the same way. So now we run this script. What does this script do? Well, it needs to somehow test Xen. So what it's going to do is launches QEMU. This is full system emulation QEMU. It's not KVM. It's plain QEMU trying to emulate a full ARM64 machine. And the same is true for the x86 test. It's full QEMU trying to emulate a full x86 machine. And then you tell QEMU to load the Xen binary somehow. You are free to choose how. And you connect to the serial, and you check the serial logs carefully to see that the logs reach the point that they want to reach. So let's say that you want to run dom0 test. You are just checking that you are reaching the full dom0 boot. So the last, the login prompt or whatever is the key log message that you want to reach. Now this is where things get very interesting. So what about if you want to run the real, Xen on real hardware? So the very first hardware runner is my terminology, it's not a GitLab terminology. I don't know if it's the best name for it, but it means you're running Xen bare metal somewhere. The first runner was Xilinx runner, is in my office in San Jose. So you cannot run the GitLab runner on the same board that you want to test Xen, right? It is not possible. So at least not with any, not without extremely clever tricks that I don't have any. So what we currently do is the runner runs on a Dell x86 workstation. This is a plain old Dell x86 workstation, one of many we have in the San Jose office. Then the workstation itself then is the one running the runner. That means that's x86, right? So you have a Debian unstable running. You have Xen.git, the Xen binary, and you run a script as usual. However, this time the workstation is connected to a board. I mean, literally connected with cables to a board. And the board is Xilinx GCU102. It's an ARM64 board. So there is a serial connected directly to it. There is also a PDU connection. That's over Ethernet, so there is not direct connection, but still connected to a PDU. PDU is a thing, for people that don't know, that can turn the power on and off for the board. And also, there is a TFTP connection, again, over Ethernet to the board. So the way the script, you still execute a script under xen.git. In this case, the script is called Xilinx smoke.0 is actually very similar to the QEMU script, except that instead of getting QEMU to run and making sure the logs are correct, you use the PDU to restart the board, you place the binary in the right TFTP directory, and then you connect to the serial. This time is a real serial. It's a TTI USB 0 instead of QEMU serial, still the same thing. And then you check that the logs are correct. So the script is like 90% or common with a QEMU script. However, what it does, it triggers a real board reboot. It connects to the real serial of the board, and there is a real TFTP server running, rather than whatever fake TFTP server you use with QEMU. To get this to work, you basically just need a controller PC that can run the runner, and you need a serial connection to the board. You need somehow to be able to trigger power on and power off, which we are doing with a PDU, and you need a TFTP server. All of these are easily exportable inside the container. So GitLab has a config file. The GitLab runner is a config, plain text config file, and you can expose. You can tell the GitLab runner, I want to expose certain things inside my containers. And in this case, what we expose is TTY USB 0. I want TTY USB 0 inside my container. Fine. I want, server, the var and run TFTPD, whatever is your path to the TFTP server, exposed inside the container. And I am assuming that the Ethernet is enough to, the networking on the container is enough to reach the PDU. And that's pretty much it. So after we got the Xilinx runner up and running, it didn't take us long to get other hardware runners up and running. So now we have 2 more runners from Cubes, which I'm not going to go into details. There is going to be soon after this detailed talk from Marek about the Cubes runner. But what I mean to say is it took hours, not days, to get the Cubes runners running. Right? It is not that hard. Which leads me to encourage everyone in the community. Do you want to make sure Xen does not break on your hardware? Get a runner up and running. And then it's going to be continuously tested. We have staging continuously tested on both the Xilinx runner and the Cubes runners. So now you really can make sure Xen releases are not going to break on your favorite board. As an example, like in the past, I wish we had this years ago. We had, in the early days of Xen on ARM, a number of boards that were a bit flaky, like you never were really sure if Xen would boot on them. And one of them, still is the Raspberry Pi target. It's not, it's not what you would call a very standard ARM64, very standard compliance ARM64 board. So with this, we don't have a Raspberry Pi target today, but if we had it, we could make sure that Xen never is going to break on Raspberry Pi or any whatever other board you would like, including x86, of course. So as of today, we have 3 hardware runners, 2 from Cubes, 1 Intel, 1 AMD x86, and 1 Xilinx GCU102 board running ARM64 tests. So like I said, if you want to have your own runner, you need to have the board, but also a controller, which in my case, I'm using an old Dell workstation. I think Cubes is using a Raspberry Pi as controller. Is whatever you can, whatever can run a container. It's good enough as a controller. You need to have the serial connection. You need to have the PDU or whatever mechanism you want to have to power cycle. and the TFTP server typically to get the binary loaded, and that's pretty much it. One thing I want to also highlight about the, this hardware runner test, and this is true actually for both the hardware runners as well as QEMU tests, we don't do any installations. So all of these tests are based on DOM0 running from RAM. So what we have is we have an Alpine Linux-based rootfs, which just runs as a RAM disk. So you just have this binary ready, and you simply boot it. There is no installation step and test step. You just put DOM0 from RAM, and you do all of the operation that you need there. Let's say that you want to have DOM0 starting 2 DOMUs. We do have tests like that. Actually, the x86 test is exactly like that. So you would add the DOMU RAM disk inside the DOM0 RAM disk and still run it everything from RAM. So you boot DOM0 from a RAM disk and then do Excel create as the DOMU is also on a RAM disk. So no installation are necessary so far for any of the tests that we have. We have 127 jobs today, I mean, including the build jobs and the test jobs. So this is an incredible amount, and I think, I mean, I'm going to make the claim that we already test more things that OSSTest ever tested. We including S3 suspend resume tests, as well as a detailed DOM0-less test, all sort of combination. And I'm not going to go through all of the tests that we have because literally we have too many. But I'm going to tell you some of the ones we have. So the Xilinx hardware runner is able to boot 2 DOM0-less VMs with PV network between them. It's also able to boot 2 DOM0-less VMs with device assignment, assigning the network device to one of them. Now, the Cubes runners are able to start DOM0, PV, or PVH, and create PVH or PV and HVM guests, are able to test PCI pass-through and S3 suspend resume. And the QEMU test is the biggest set that we have, so those are really very many. So on x86, we have XTF tests, and we have DOM0 booting and creating guests. On ARM64, we really have too many to name. So we have DOM0 booting and creating guests, DOM0-less boots, DOM0-less boot with PV network, static share memory between guests, CPU pools, static heap. We even have true DOM0-less tests without a DOM0 and DOM0-less only. And we have, we're starting to have RISC-V tests that test basically as far as Xen is able to boot on RISC-V.
And PowerPC now.
And PowerPC as this week, yes. Okay, so now MISRA-C and GitLab. So one feature of GitLab that many of you, are probably not aware of, and I myself tend to forget about it, is we have patchu. So patchu is this thing that pulls email from XenDevel, applies them to a Git branch. Well, and if you know GitLab, if you commit to a Git branch, that triggers a pipeline. So what it means is we have GitLab pipelines and tests for random patches sent to XenDevel. We tend to forget them because for somehow the notification from patchu are lost. So we don't really have email notification to XenDevel, and this is one of the probable complaints that Andrew is going to tell you more about. But if you go to gitlab.com/Xen Project/patchu, you can see, right, what passing and what's not passing from patches contributed from the list. Now, this is interesting on itself because it means that as a reviewer, maybe you're not that sure about a patch, and is this really working? And you can go and check on patchu as it's really been tested already. There is a good chance patchu already applied it, GitLab pipeline was started and completed already before you even read the patch. So you
particularly if it's the next day you come to read.
Exactly, specifically it's the next day. So you want to make sure that you want to review a patch that at least builds. You can go in there, check that it's passing all the build tests. in GitLab and only start the review after, right? Or do you want to take credit for doing good reviews without really doing a lot of effort? Go and check if GitLab fails and then report all the build failure or your clever finding on the review of the patch. Anyhow, so this is interesting, but more interesting is when you put Misra into the picture. Because, I mean, Misra violation can be very detailed and finding some actually interesting defects on a patch. And one of the goals of Misra from the beginning was to make review easier by automatically check for all of these violations using automated tools. What we have today is CPP check. So CPP check is an open source Misra C scanner. It's very limited in all honesty, but it's also open source, and you can install it on any, Debian or whatever. Use your favorite distro. You can install CPP check and run the scan yourself. We already have a CPP check job, but we are also working closely with Xen. And you should see progress here in the next couple of weeks. We are working on adding an Eclair job as part of the GitLab-CI. What this means that together with Patchu, we are going to get automatic Misra C scans from a very, very detailed and accurate Misra C scanner like Eclair. You should know that Eclair is itself safety certified, to tell you how well written and how accurate it is, on every patch that comes in. The goal here is to have the Eclair job fail only, not if there is just one violation, but if there are new violations introduced compared to the baseline. So the idea is a patch comes in, the job fails, is that specific patch is introducing bugs compared to the baseline. The goal of this is really to make the review easier and spot a wide range of issues automatically with using, checkers. Okay, so another thing that GitLab makes very easy is to have private pipeline. So if any of you have ever tried to debug something specific with OSSTest, you might know that it's possible somehow to trigger special job with OSSTest. I have a long document explaining how to do it. I never managed to do it myself because it's not trivial, right? I mean, it has been done several times and for a number of reasons, including testing security fixes, but it's not an easy process. With GitLab-CI, it's super simple because any one of us, and many already do, including me and Andrew and many here in this room, have their own GitLab tree. So gitlab.com/Xen Project/people/Stabellini or Andrew Cooper or Bertrand and so on. As soon as you push to any of those trees, a GitLab pipeline is triggered and you see the result. So literally to have your own private pipeline, you just need to do one git push and that's it. So that can be used for any sort of things, including testing your own, in development code, in development patches, to test someone else's patches because you're not fully convinced that they work as those guys claim they do, or whatever reason. You can trigger your private pipeline today extremely easily. Now, the next step is to do this automatically for staging. And this is what we talked yesterday in the design session, we want to block bad patches, bad commits from even entering staging. And this can be done with the merge request scheme where the committers push to their own private tree, triggering the pipeline, marking it as a merge request, and then if the pipeline succeeds, those patches are automatically committed, moved to the staging tree on GitLab in a fast-forwarding way. On the other end, if they fail, the committers get a notification of the failure. And effectively what this means is GitLab-CI becomes gating. So effectively what it means is, if something breaks GitLab-CI, it's not going to enter staging, unless the committers want to, of course, but not by default. This is better than what we have today with OSSTest. Because what we have today with OSSTest is we have to commit to staging, wait a day, and then if it's broken, it's broken. You know, we can't take it out.
Next day if you're lucky.
Yeah, exactly. One day if you're lucky, and then you have to revert it. So in the best of cases, you will get a commit and the revert commit, right? This is not ideal. With GitLab-CI, first of all, if you are in the right time zone, it takes 45 minutes. For Europeans, I think it more likely will take 2 hours. It's still not 1 day. But secondly, the commit is not going to enter staging at all, right? So we have a much cleaner Git history that we're going to end up with. So this is I think this is the last slide on my part, and I'll let Andrew continue with some of the outstanding issues that we have or future developments. But I want to say that, you know, GitLab-CI is extremely powerful and easy to extend. Way, way more than OSSTest or anything we had before. It's extremely easy to have your own hardware runner. So you have a spare board on your desk. You can set up your hardware runner, hook it up on GitLab-CI in Xen Upstream, make sure your board does not, you know, Xen does not break on that board. And you can very easily trigger private pipeline, and many of us already do, is one Git push away, you know, to your private pipeline. And soon we're going to have MISRA-C scanners, and that's going to be, to me, a total game changer, because I think many of the review issues that we, you know, many of the issues we do are things that a MISRA-C scanner will be able to detect automatically. And finally, we're going to have a staging tree free of reverse. Well, not entirely free of reverse, but freer of reverse commits compared of today. And with that, I'm going to leave it to Andrew.
Okay, so this is a few bits and pieces. Obviously, GitLab's still a work in progress. We have spent a large amount of time trying to get it going, and it's always in copious free time, as you're all aware. One of the things we have, at the moment in the OSS test lab, there are idle runners, things that have been racked and haven't been wired in properly. We are looking to try and use those to add capacity into the regular CI, system. The other thing is, I know we're on a GitLab talk, but it isn't only GitLab that we use. We do have some GitHub actions in there as well. The reality being, it's free for us to use, it's great. In particular, we have Cirrus CI set up. So Cirrus CI is a third-party CI/CD system, but it's free for open source to use. And one of the things it can do is launch FreeBSD builds. So it's running FreeBSDs on, I think, Google Compute. 10 minutes, and you get a build out of FreeBSD. And FreeBSD spots quite a lot of bugs that we don't really notice too well in the otherwise exclusively Linux environments that we test in. So that's good. We've also got it being the thing that triggers covariety static analysis at the moment. That's on a schedule. We have some improvements we'd like to do with that. There's a lot of stuff we'd like to extend. One of the things that's happened in GitHub is they've integrated CodeQL, which is a new static analyzer. It has some rather interesting properties about it. I think Roger posted some patches. We need to find time to fix them, get them committed. As I said, copious free time. One of the things we'd like to do is cross-link this into GitLab, because obviously people don't want to be maintaining both of them together, but we think it should be possible to have GitLab check that GitHub either came back saying yes or no, and make that available to you in one UI. Obviously, you'll have to follow links to the other one, but it should be fine. We have more time than we were expecting, so have extended it by a slide or two. We've been doing this for, what, 2 years now. We have discovered the hard way some of the issues with using containers. We're still trying to clean up a few bits and pieces. So in particular, one of the problems we have is the containers are static from the point at which they're created. And we discovered this the hard way when trying to enable HTTPS everywhere. Because the Let's Encrypt root certificate that was embedded in our containers had been revoked at the top level, and at which point you try and build over an unencrypted Git clone, and it worked perfectly fine. And you tried to do the securer version of turning on HTTPS, and everything broke. We're looking at trying to rebuild the containers automatically, and that actually finds a second problem that is more subtle and you do need to be aware of. The containers are global for all versions of the project. So the container you update to run on staging is also the same container that's running on Xen 4.14 for a really old branch that's only in security support. And right now, every time we change a container, we break the old staging trees. I was hoping to say that was all fixed, and then I tried pushing some stuff earlier this week, and we've regressed it even more. We're hoping to put together some rules and guidelines on how we should go about trying to create and maintain containers, learning from the lessons we have already tripped over. Obviously, we're still trying to learn as we go. This is a collaborative process. The main issue that we have at the moment and still needs working on in our copious free time is that a lot of the containers are based on the bleeding edge, so Debian unstable or OpenSUSE, Tumbleweed, things like that, which means that every time you rebuild them, you get a completely different internal layout if someone updated the container.
For the staging tree.
For the staging tree, yes. So what we're looking to do is try and explicitly tie ourselves to known stated versions, at which point, when you update the container, you don't break the old trees, but moving forwards, you would pick a newer version. Pick a newer version in staging, at which point we hope that will reduce the number of times I have to go back to the security-only trees and commit 15 patches worth of GitLab fixes in the hope that we can get the build tests working again. As I said, we're very much learning as we go here. We're making progress. We certainly like the outcome that we're getting to. And at that point, any questions?
Yeah, so I just had a question about the, for OSSTest, it has a pool of machines that it can run stuff on, and it kind of chooses one randomly and then runs it, and then if it fails on that machine, then it tries to sort of like rerun the test on that machine like several times to see if it keeps going. Like, how does GitLab at least have the thing where it says, well, okay, there's 10 different identical ARM boards here, I'll just run it on one of them, or will it always run on all of them? And anything like that.
We don't really have that at the moment. All the individual boards are tagged individually for the real hardware. The common runners, they're just Docker containers on a regular Linux. You pick the one that you get allocated next. And yeah, there's a potential to have variations between the runners, but they're supposed to just be an up-to-date Ubuntu running an up-to-date Docker runner.
Well, I'm just kind of wondering, so if I had the identical thing that Stefano did.
For the hardware runner, keep in mind that GitLab only see the controller, not the board.
Okay.
Right? What it really cares is about deploying the container, like Debian unstable, on the controller PC.
Yeah.
And then the controller PC can do whatever it likes.
Right.
So I think already Marek kept thinking about how to lock in the controller PC boards if you are running multiple kind of tests. Or so if the controller is capable of understanding being connected to 10 machines and picking the first one that's free, that's totally okay.
Okay.
My controller cannot do that yet because I only have one board today.
Sure.
But I could connect 3 boards. And then what I will do is I will connect both, all of 3 to the controller node, and then the controller node will figure out where to send the test. So this is something that needs to be done inside the script that we completely control. So it's possible to do it, but we haven't done it yet.
Right. Okay. So within one kind of thing, like a test system, you could do that. But if there was a second system that also had if OpenXT added a thing with also like their load of laptops, then there might be duplicated. I mean, it might maybe what you want, but you might be duplicated.
So what you need then is what Marek, and then, I don't know if you're going to talk about that in your talk, but you need a way to lock the board across different systems.
Okay.
He already does that.
Okay.
So yeah.
Okay. Other questions?
Just one thing, you said that if we have a board available on our desk, we can connect it to it. Just bear in mind that there are security issues if you do that from the network of your company. Even if GitLab would allow you to do it through gateways and stuff like that. So be a bit careful with that.
It's fine. No one can actually get a runner into GitLab without going through one of the admins, which is at the moment Stefano and myself.
Yeah.
So
Is there a restriction on how the test can be run in GitLab, in GitLab, and there are not that many people that can trigger hardware tests. So it's not like a run Patchu. Let me take as the best example.
we specifically don't want Patchu running stuff off the general internet on people's hardware.
Exactly.
Okay. Yeah, I'm afraid we have to go to the next talk. So thank you.